Okay, class. So we can take our topic, that is ionization constant of water and ionic product. Okay. For this, we can consider a simple reaction between an acid HCl and water. Here, HCl will donate this H plus. So H plus donor will be acid, and this H2O this H2O molecule will accept H plus, and H plus acceptor will be base. Okay, so HCl plus H2O, and these are in equilibrium with hydronium ion and chloride ion, because hydronium ion can release H plus, so it will be conjugate acid, and this chloride ion, because can accept H plus, so it will be conjugate base. Now in first case, we can see that here H2O accept H plus when it in contact with a strong acid. So due to acceptor of H plus, here H2O behaves as a base. Again listen. So when H2O reacts with HCl, so here H2O behaves as a base, because here in this case it accepts H plus. Now in second case, we can see that when we take this ammonia and H2O, okay, so ammonia can accept H plus from water, so ammonia here will be a base, and H2O here, because it donate H plus, so it behaves as an acid. Okay, and these two are in equilibrium with ammonium ion, which is conjugate acid, and OH minus ion, which behaves as a conjugate base. So in second case, now this H2O behaves as an acid because it donate H plus ion. It means when H2O in contact with acid, it behaves as a base due to acceptance of H plus, and when H2O comes in contact with a base, it will behaves as an acid because it will donate H plus. Now if we write an equilibrium equation only for pure liquid, here we have taken two molecules of H2O. Now one molecule H2O now here release H plus, so it can be considered as an acid, and another which accept H plus can consider be a base. Okay, and these are in equilibrium with hydroxyl ion and hydronium ion. Okay, now here one water molecule, because it donate H plus, so it will be it behaves as an acid, and another because it accept H plus, so it behaves as a base. Okay, now if we write equilibrium expression, so that is equilibrium constant K can be written for this equilibrium reaction as what? K is equal to OH minus H3O plus by H2O. Now here question arises, we have taken two molecules of water, but we have not write here square. Why? Because even in a single drop of water, there will be millions of water molecules, so no need to write here square. Second reason is that because water is a pure liquid, so its molar concentration taken to be constant. Okay, so no need to write here square. Now in this case, here K is an equilibrium constant, and H2O is what? H2O is molar concentration of water, which is also a constant, and in later we will see that molar concentration of water taken to be 55.55 mole per liter. So in place of these two constant, we can introduce a new constant, that is Kw, which is called ionic product of water. Okay, this ionic product of water. Now, so now here K into Kw, we can write what? Here K into H2O, we can write what? Kw, that is ionic product of water. So now Kw can be written as, now here Kw can be written as OH minus H3O plus. Now interesting point is that experimentally it is found that in pure liquid water, this concentration of hydronium ion or H plus ion found to be 1 into 10 to power minus 7 m. So experimentally it is found that concentration of hydronium ion or of H plus ion in pure water is 1 into 10 to power minus 7, and you can see here that number of OH minus ion and hydronium ion. So in liquid water, actually H plus and OH minus ion concentration will be same. Okay, so if concentration of H3O plus ion taken to be 1 into 10 to power minus 7, concentration of hydroxyl ion will be also 1 into 10 to power minus 7 m. And in this way, value of Kw, that is ionic product of water, will comes as 1 into 10 to power minus 14. Okay, so ionic product of water, that comes to be 1 into 10 to power minus 14. Now interesting point is that because concentration of hydroxide ion and hydronium ion H plus ion in water is same, that's why water is neutral. Okay, now if we consider that ratio of dissociated water 10 to power minus 7 m to undissociated water, that is 55.55 m. So its value comes to be 1.8 into 10 to power minus 9, or approximately 2 into 10 to power minus 9. Now this value is very less, and that's why in water our equilibrium will generally shifted in reverse direction, because here value of Kc or of Kw is very less, that is 10 to power minus 9. Okay, so due to very less value of this dissociated and undissociated water ratio, now which is 10 to power minus 9, equilibrium in pure liquid shifted in backward direction. What is meaning of this? Simple meaning is that in pure liquid, now undissociated water present in larger extent as compared to dissociated water. Thank you class.